Hello everyone. Today in this chapter, I want to discuss about angle and its measurement. This is the first chapter in 11th standard in the science portion. So 11th science, the first chapter is called as angle and its measurement. This particular chapter will study about the angles. Then I'll explain you different types of angles. Then we'll discuss about coterminal angles, which is slightly more important. So we'll come to about coterminal angles. This portion is important. After that, we'll try and do few questions on degree and radian. How do we convert an angle which is measured into degree into radians? And how do we convert radian into degree? These are two things. Lastly, we end this lecture by expressing degrees in terms of minutes and seconds. This is the first part. Now suppose, let's start. There's an initial arm OA and there's an arm OB. We start an angle from OA and end on OB. And this angle is called as 45 degree. This will be measured as an angle, a directed angle, which is an angle 45 degree. Now this 45 degree is positive because we are measuring it in anti-clockwise direction. So whenever the angle is measured in anti-clockwise direction, it is positive, which means if there's an angle like this 60 degree and I measure from here to here, that is, this is called as anti-clockwise direction. This is called as anti-clock, against the direction of clock. Clock moves like this. This is called as clock. This is anti-clockwise direction. So this angle will be called as plus 60 degree. This will be positive. That's the first part. Suppose there's an angle, initial arm OB, and we are measuring this angle from OB to OA. This is also 45 degree. But since we are measuring in this clockwise direction, this angle will be called as minus 45 degree. So there will be a negative sign, minus 45 degree. This negative sign indicates the direction is in clockwise direction. Remember this. This is the first basic concept in measurement of an angle. When angle is measured in clockwise direction, it is positive. It's negative, whereas it is measured in anti-clockwise direction, it is positive. Now let's learn something more. Now there are different types of angle: zero angle, straight angle. Let's understand them. First one, zero angle. Now if this ray OA is there, as it is shown here, OA is the first ray, that it does not rotate, and there is an OB, the angle so formed between the two, that is, this is OA and OB. There is no angle between them. So both rays are overlapping. In such situation, it is called as zero angle. Simple concept. There is no angle between the two rays. That's called zero angle. A straight angle. Now here it is OA and here it's OB. Now they're in the opposite direction. There's an angle OA to B. This angle will be 180 degree. This is called as straight angles. After the rotation, if initial arm OA and terminal OB in the opposite direction, the angle is called as straight angle. This is called as 180 degree and straight angle. Similarly, if there's an arm OA and there is an arm OB which are at right angle, then this is called as a right angle. As simple as that. So you've basically studied what is straight angle, right angle. This angle AOB will be called as, now here you remember the direction plays a very important role. So for example, when I were measuring angle AOB, this will be 90 degree. Whereas angle AOB dash you are measuring is minus 90 degree, because this is in clockwise direction and this was in anti-clockwise direction. That's the basic concept. Let's try and understand something more. Angle in a quadrant. Now when there is an angle which is part of one quadrant, so for example, this particular angle is 90 degree. This angle is touching the first quadrant. That is an angle in a quadrant. So any angle in the respective quadrants are called angle in those quadrants. This 30 degree will be in first quadrant, whereas beyond 90, that is 120 degree, will be in second quadrant. So all which are 0 to 90 are in first quadrant, 90 to 180 is in second quadrant, 180 to 270 is third quadrant, and 270 to 360 degree is fourth quadrant. Now let's understand a very important concept which is called as coterminal angles. Now what are coterminal angles? We will take an example. Directed angles of different amount of rotation having the same position of initial and terminal is called as coterminal. Now what happens is this is OA and this is OB. Now there's an angle between them is 30 degrees. This is 30 degrees. Simple angle AOB is 30 degrees. Now what I do is I try to find out, I go from here, rotate it and try to till here, come back to this point. So I've started from OA and gone all the way and touched B. In this case, what I have done is I have completed one complete circle, and one complete circle is called as 360 degree. One circle is 360 degree, which is still here. From here to here, I have covered further 30 degrees. So 360 plus 30 degree is equal to 390 degree. Now these two angles, 390 degree and 30 degree, are said to be coterminal. Why? Because both of them have started from the same ray and ended on the same ray, which means if you see clearly, it started from OA, ended on OB, that is 30 degree. Similarly, it started from OA and gone all the way and ended here. It is 390. Further, if I start from here and if I start from this particular point and go like this, another circle like this will also be called coterminal. In this case, the first angle is 360, then second 360 plus this 30. That will be 360 plus 360 plus 30, which is 750. So that angle 750, angle 390, and angle 30 all are said to be coterminal. So remember that is one. There is one more angle which is coterminal to it. So if you see clearly in this diagram, there is an angle which is opposite, which is this angle. It is starting from OA and ending on OB, this particular angle, and that is in a clockwise direction. So if you see, this complete circle would have been 360, out of which I have removed this 30 because it's not completed 30. So the angle is 330, but it is in the opposite direction, that is in clockwise direction. So this angle will be minus 330 degree. Remember this, from here so this entire portion is 360, but I am not completing the entire thing. I am only doing this much. So from 360, I have removed 30. This angle is 330 degree, but in the ulta direction, that is in clockwise direction. That is why it is called as minus 330, which means minus 330, 30, 390, 750. All these are coterminal angles. Try and check the other questions which I've explained in the class. You can try and see if 40 and 400 and 760 are coterminous or not. Just check this at your, that was coterminal. Now let's move on and I try to explain concept related to degree. And there are two ways in which a angle is measured, either in terms of degree or in terms of radians. Now degree is, one complete circle is said to be 360 degree. So 1 degree is 1 upon 360 of the entire circle. Entire circle measures 360 degree. Therefore, 1 degree will be equal to 1 upon 360th of a circle. That is 1 degree. Now similarly, if we have 90 degree, 90 degree will be 1/4 of a circle, and so on. But for us, the most important part is you should remember the calculation or the conversion between degree and radians. Now the entire circle is said to be 360 degree in degree terms. This entire circle is said to be 2 pi in terms of radians. So you have to remember this, both are equal, which means 360 degree is equal to 2 pi. Therefore, 1 degree is equal to 2 pi upon 360, which is equal to pi upon 180. So whenever I have to convert a degree into a radian, I have to multiply it by pi upon 360. Let's take an example. 60 degrees. I can write it as 60 into pi upon 180. 63 is a 180. This can be written as pi by 3 radians. So the first concept you should clearly remember that degree to radians can be converted by multiplying the degree into pi by 180. You can take another example of say 70 degree, or you can take an example of say minus 120, whatever, whichever way you want to take, you can take any one of the examples. I will supposedly take an example of give me a minute. Let me take an example of minus 120 degree. Now in minus 120 degree, if I take minus 120 degree, this can be taken as minus 120 degree. If I convert, I told you that particular angle minus 120 into pi upon 180. Here 62 is a 120, 63 is a 180. This will be minus 2 pi upon 3 radians. This is how you convert degree into radians. Now let me try and take few examples of degree into radians. That was the first part. A degree into radians, let me take a example. Let's try to take radians into degrees. Radians into degree. How do we convert radians into degree? We will take suppose 2 pi by 5 radians. We will multiply this with 180 upon 5. Here it is ulta. There we were multiplying by pi by 180. Here we'll multiply by 180 upon pi. We will cancel out this pi and pi. 5, 36 is a 180, and 36 into 2 is 72 degrees. This is how you can solve this question. So degree into radians and radians into degree. So we have to convert degree into radians, we have to multiply pi by 180. And you have to convert radians into degree, you have to multiply by 180 upon pi. And now the last part, I'll just try to take one further question, which is related to concept of, we'll take this question, express the following angle. So let me just try and delete this part and try to take this part and also delete this part, and then we write this. Express the following angles in degree, minutes and second. In this last part, we are going to study about, in this last part, we will study about 74 degree. So we have to remember that 1 degree can be converted into 60 minutes. It's called like this, 1 dash, 1 degree 60 minutes is called as minutes. Then 1 minute is equal to 60 seconds. So this is called as seconds. Double dash is called as seconds. Let's try and take the first question, which is 74.87 degrees. How we will write this is, we can write 74.87 degree. We can write it as 74 degree plus 0.87 degree as it's a decimal. Further, we'll try to solve this 0.87 degree. What we will do is, we will try to solve it here. 0.87 degree, as I told you, 1 degree is equal to 60 minutes. This can be written as 0.87 into 60 minutes. So 87.87 into 60, if you multiply, you will get a value of 52.2. So I have converted it into 52.2 minutes. Again, this part is decimal. I can write it as 52.2 minutes are equal to 52 plus zero point 0.2 minutes. This 0.2 minutes also I have to convert into seconds. So I know 1 minute is equal to 60 seconds. Therefore, 0.2 minutes will be equal to 0.2 into 60 seconds. So which is 12 seconds. Which means that 0.87 degree can be written as 52 minutes, and I can write it as 52 minutes, that is this, plus 0.2 minutes, which is 12 seconds. So I can further write it as 0.87 degree is nothing but 52 minutes and 12 seconds. We can write like this, and we don't have to write any plus or something. Now this can be substituted back to our original question here. What we will write is, we will write 74 degree plus, instead of 0.87 degree, I will write 52 minutes and 12 seconds. This can further be written as 74 degree, 52 minutes and 12 seconds. This is how it has to be written. Express the following angles in degree, minutes and seconds. Please practice the second question. A hint for the second question would be that you need to write minus 30.6947 degrees is equal to, माइनस कॉमन ले लेंगे, 30 plus 0.6947 degrees. And this 0.6947 degree, you will do exactly what I did here. First convert, multiply by 60, you will get in minutes. Whatever is decimal, multiply by 60, you will get into seconds, and try to substitute back. That's all I wanted to complete in this. Please go through this video once again, and I will share the second part after some time. Thank you so much.